So finding the domain of the function f of x equals the square root of 6x minus 5. Anytime we have an even index for a radical, we know that that domain is going to be limited uh, because what is under the radical must be greater than or equal to 0. Now, at least for now, in the real number world, we're not looking at the complex number system yet. In the real world, if you want to call it that, uh, 6x minus 5 in this case would have to be greater than or equal to 0. We can't take the even root, in this case the square root, of a negative number. So to find the domain of a radical function with a limited domain like this, we simply set that inequality up and solve. So we have 6x minus 5, what's under the square root radical, is greater than or equal to 0. Add 5 to both sides, and we have 6x is greater than or equal to 5. Divide both sides by 6, and x is greater than or equal to 5/6. Now we're asked to give the solution in interval notation. So what does this mean? Well, this means that x can be any real number greater than or equal to 5/6. Now that equal to means that we'll have a square bracket on the left-hand end. If it were just greater than, it wouldn't include the left-hand end. It would just be greater than, and we'd use a typical parenthesis. But in this case, it is inclusive. It includes the equals. And we know it's greater than or equal to 5/6, so we start at 5/6 as our left endpoint. And there's no other stipulation. It just has to be greater than that, so it goes on infinitely. And when we have infinity or negative infinity, it's always indicated with an open bracket. So for the domain of f of x equals the square root of 6x minus 5, since it's a square root, we set what was underneath the radical greater than or equal to 0 and solved. And then for interval notation, it's inclusive, so a square bracket on the left going to infinity with an open bracket on the right. So the domain is 5/6 to infinity.